Let's talk about problems involving an equation. So we talked about dimensional analysis and how important it is, but sometimes we have to use equations instead of using dimensional analysis and conversion factors. The equation here then is the relationship between the given quantities and the quantity they're asking you to find. So what will happen is you'll have an equation like PV equals nRT or D equals M over V or something, and you'll be able to find out all of the variables except one. And so then you rearrange the equation and solve for that variable, and then you plug the numbers in. So an example would be this one. Find the radius of an aluminum cylinder that is 2 centimeters long and has a mass of 12.4 grams. And then we're given the equation describing the relationship of volume, length, and radius for the cylinder. So we look at this. We've got the volume of the cylinder equals pi, the radius squared times the length. Well, what do we know here? We know the length, so this 2 centimeters, it says it's 2 centimeters long. So that's the length. The length equals 2.00 centimeters. I changed the tip of my stylus and now it's not behaving well. And then they're giving us the mass. We usually use mass as M. The mass is 12.4 grams. And we're trying to find R. Well, what we need to do is we need to rearrange this equation. So this is basic algebra. If you have issues with rearranging equations, get help right away because this isn't going to go away. I can teach you how to do it. So if I'm solving for R, what I want to do is I want to get rid of the things that are with R on the right side of the equation. So if I divide this side by pi, pi divided by pi is 1. I can cancel those out. But now this equation isn't an equality anymore. It's like a teeter-totter, and I put a rock on one side. It's going to tip. It's not balanced. I have to do the same thing to both sides. So I need to divide the other side by pi. And then I want to get rid of L. So I'm going to divide the right side by L. So the L's cancel out. Then I also have to divide the left side by L. So let's take stock of what we've got here. I've got R squared is equal to the volume divided by pi times the length. I don't want R squared. I want R. What do we do to get R from R squared? Take the square root. So I'm going to take the square root of this side, and I'm going to take the square root of the other side. If I take the square root of something that's squared, it just becomes the something. So there's my equation. I'm trying to find R. It says find the radius. They gave me the length. I know what pi is. I'm just going to use the button on my calculator. I need the volume. I'm going to use the mass and the density. Okay. Now you can solve the density equation using algebra. And if you're good at algebra, you go right ahead. My experience is that students make a lot of stupid mistakes when they do that. And so I would like you to learn how to use density as a conversion factor. I should have looked this up. What is the density of aluminum? Let's test Siri.
Let me have a look. Here's what I found on the web.
No, I don't want what is the density of aluminum stuff, Siri. Stop it. Okay, let's try again. What is the density of aluminum?
The density of aluminum is about 2.7 grams per cubic centimeter.
Thank you. 2.7. Is that cheating? No.
It's not a test.
We're not on a test. If you use your cell phone on a test, you're in trouble. But homework, sure, why not? Okay, so there's my density. I want to use dimensional analysis. Here I've got mass, and I want to get to volume. Well, a unit of volume would be cubic centimeters. So I'm going to take my 12.4 grams, and I'm just going to have one factor here. I want cubic centimeters on the top and grams on the bottom. The units tell me what to do. Then I look at the density. 2.7 is with the grams. So 2.7 is down here. And per centimeter, that would be 1 centimeter. So then I take my calculator, and I've got 12.4 divided by 2.7. So this equals, how many sig figs would this result have? 2, because of that density. So, if I was serious about this, I might want to find a more precise density. So there's my 2 sig figs, and then I'm going to put down 2 more, and that's going to be cubic centimeters. That is my volume. Now I have the volume and the length, and I can put them into the equation. So the volume is 4.593. I underline the 5 to remind myself that that number only has 2 sig figs. Cubic centimeters, always write your units, divided by pi times L, 2.00 centimeters. And then I'm going to take the square root of the whole thing. When you are dividing by 2 numbers that are multiplied by each other, be careful. So if you have your calculator, which you should, do this calculation with me and make sure that you know how to tell your calculator what to do. So I have a TI-36X Pro, and so what I'm going to do is I'm going to press the square root button, and then I've got 4.593 divided by pi and divided by 2.00 equals. And I come up with this number, 0.85498. There's some more. What would the unit be on that?
Centimeters.
Centimeters. Because what happens here is that centimeters cubed divided by centimeters gives me centimeters squared, and then I take the square root of that, and so that's centimeters. Make sure that you can get your calculator to show you that number. How many sig figs? 2. Taking square roots could mess things up a little bit, but we're not going to worry about it. So 0.85 centimeters is the radius of my aluminum cylinder. Any questions? That is a straightforward problem. It requires you to do a calculation to find one of the numbers that you need for the equation. You have to rearrange the equation. This is a very common type of a Chem 1A problem. We wouldn't give this to you in Chem 3A. But you could have a question like this show up on an exam that we haven't actually done in class. So you just need to be prepared for that. Any questions? Let's do this one. Find the density in grams per cubic centimeters of a metal cube with a mass of 50.3 grams and an edge length of 2.65 centimeters for a cube. Volume equals length cubed. I would like to believe that you all remember your equations of volume from geometry, but I'm not going to count on that. So this would be a good test question. I'm giving you the equation for the volume, and you've got everything else you need there. So it says find the density. What's the equation for density? Mass divided by volume. So density equals mass divided by volume. And the units here suggest that. This is a mass unit divided by a volume unit. So if you were a little unsure, was it volume over mass or mass over volume, the units are a big clue there. Units are your friends. Make friends with them. They can help you out. So I need the mass and I need the volume. Well, they gave me the mass. Okay, so density is the mass, 50.3 grams, divided by the volume. They didn't give me the volume. They gave me an equation. Volume equals the length cubed. But they did give me the length. So I need to calculate that. 2.65 centimeters. And then that whole thing is cubed. So on my TI-36X Pro, what I'm going to do is I'm going to do 2.65, and then I have an x to the, it's just a little square, x to the square button, and then I'm going to put the exponent in there, 3 equals. And this is going to give me 18.6. This should have 3 sig figs, so there's my third sig fig, and I'm going to write down a couple extras, 0.96. And the unit would be centimeters cubed, because we cubed centimeters. You could also do that by taking 2.65 times 2.65 times 2.65. That would work as well. But every time you punch numbers in, you have the possibility of making a mistake. So there's my volume. I'm going to put that into my equation, 18.6096 cubic centimeters. Underlining the 6 to remind myself that number only has 3 sig figs. And then I'm going to do the math, 50.3 divided by 18.6096 equals 2.7, 3 sig figs, 0, and then write down 2 extras. The units are grams per cubic centimeters, and then round, 2.70. What metal do you think that cube is made out of? What was the metal in the previous problem? Aluminum. Aluminum has a density of 2.70 grams per cubic centimeter. The density is actually a fairly good way of identifying pure elements. Any questions?